When a transformation is applied to a function, the rule for the function often changes. Sometimes this effect or change in the appearance of the rule is described as intuitive, and at other times counterintuitive. Let's take a look at why this happens. Consider the function y equals x squared and apply a translation of 1 unit in the positive y direction or 1 unit up. The resulting function or image function will be a copy of the original function with +1 on the end. We associate up 1 with +1, and so in some sense this feels right. Now consider starting with the same function and apply a translation of 1 unit in the positive x direction or 1 unit to the right. We know that when a translation of 1 unit to the right is applied to a single point, 1 is added to the x value of that point. So you might expect in this case that the resulting function or image function is the same as the original, with the x replaced by x plus 1. But that is not the case. The image function here is the same as the original function, with the x replaced by x minus 1. So a translation of 1 unit to the right has resulted in the x in the original rule being replaced by x minus 1. Not what we expect. Before we see why this happens, let's take a closer look at our original function. A function describes the relationship between x and y values of points on a curve. Our original function, y equals x squared, tells us that the y value of every point on the curve is the square of the corresponding x value. The same rule can be written in the form x equals plus or minus the square root of y, telling us that the x value of every point on the curve is the positive or negative square root of the corresponding y value. Which form of the function we choose to focus on when applying a transformation depends on whether the y values or the x values are affected by the particular transformation. A vertical translation of 1 unit up results in 1 being added to the y values of each point on the original curve. With this type of transformation, the x values remain untouched. Here are a few of the image points. 0, 0 becomes 0, 1, 1, 1 becomes 1, 2, 2, 4 becomes 2, 5, 3, 9 becomes 3, 10, and so on. Here we see the original curve and its image after a translation of 1 unit up. A horizontal translation of 1 unit to the right results in 1 being added to the x value of each point on the original curve. The y values remain untouched with this type of transformation. Here are a few of the image points. 0, 0 becomes 1, 0. 1, 1 becomes 2, 1. 2, 4 becomes 3, 4. 3, 9 becomes 4, 9, and so on. Here we see the original curve and its image after a translation of one unit to the right. Before we find the image equations, let's recap the key points. The original curve can be written in two forms. A translation of one unit up affects the y values only, and a translation of one unit to the right affects the x values only. In the case of the vertical translation of one unit up, only the y values are affected, and this version of our original function will be the most helpful in finding the rule for the image function. In this case, the image y's are the same as the original y's plus 1. Now in the case of the horizontal translation of one unit to the right, only the x values are affected, and this version of the original function will be the most helpful in finding the rule for the image function. In this case, the image x's are the same as the original x's plus 1. Notice how there's nothing counterintuitive about what has been done here. The only thing that looks a little different is this rule. With x as the subject, normally we write our rules with y as the subject. This can easily be done. Subtract 1 from both sides. Square both sides. We can swap sides. And now our function is written in the way that we expect to see. Notice how when we compare this to the original function y equals x squared, the x has been replaced by x minus 1. Hopefully this example has convinced you that the counterintuitive label given to the effect of some transformations on rules is due only to our conventions in rule writing, and there is nothing very mysterious going on.